Welcome back to Vuln Vibes. For this deep dive, we're tackling something pretty serious that just landed on the advisory lists.
Ah, you mean the Elastic Cloud Enterprise issue?
That's the one. A really nasty piece of work, the Elastic Authorization vulnerability.
CVE 2025-37736. Yeah, I saw that. It's significant.
Definitely. And we're jumping right into it because, look, this isn't just some minor bug fix we're talking about.
No, not at all.
It's a critical security advisory. It's about improper authorization within ECE.
Elastic Cloud Enterprise, yeah.
Our goal here is really to dissect this thing because, honestly, it looks like a fundamental collapse of the least privilege model right at the platform level.
That's a good way to put it.
We need to figure out exactly how a supposedly basic user can suddenly grab the keys to the kingdom. We need to analyze that really aggressive CVSS score and, crucially, lock down what people must do to fix it.
And you're right to frame it that way. When you see authorization flaws pop up in core platform management tools like ECE,
which sits on top of everything.
Exactly. It manages your whole data stack, potentially. You have to treat it like a potential ZeroDay for system compromise.
Right.
It basically dissolves security boundaries you thought you had.
And the hook, the really scary part you mentioned right at the start.
Yeah, the root cause. It's labeled improper authorization.
Simple label, big problem.
Huge problem. It allows the built-in readonly user, a role designed purely for looking, not touching.
Right, visibility only.
It let that user call highly restricted system management APIs. That just screams authorization bypass. Pure and simple.
Okay, so let's unpack that. The mechanism of failure here. It's not like input validation gone wrong or something subtle.
No, this is more fundamental. It's an API access control breakdown, straight up.
So like the readonly user walks up to a door, clearly marked admins only.
Yeah.
And the door just swings open.
Pretty much. Think of it like that readonly user has a library card. It's supposed to just let them browse, right?
Yeah.
Maybe look at the reference section.
Makes sense.
But this bug, it accidentally makes that same library card unlock the main vault, the one with the system admin's master keys inside.
It's not good.
That analogy holds up surprisingly well, actually, because technically the API gateway, or maybe where ECE maps roles to permissions, it just failed.
Failed to check the card properly.
Failed to enforce least privilege. Those specific endpoints, the ones that manage creating users, changing service accounts.
Critical functions.
Absolutely critical. They should have immediately rejected the readonly user's credentials, long before the function even got close to executing.
But they didn't.
They didn't, which tells you the authorization layer itself got confused. It couldn't separate let's say, the identity of the built-in role from the permissions needed for that admin API. It's a classic kind of flaw in these systems.
And the attack surface implications. A threat actor starts with this account, the readonly user.
Which is everywhere.
Yeah.
Default installs often have it enabled.
Right. It's ubiquitous, known, low privilege. And from there, they get full privilege escalation instantly.
It dramatically lowers the bar for a complete system breach.
You don't need some complex exploit chain.
Nope. You just need the username and password for that readonly account, the equivalent of finding that library card lying around.
Which makes the vector itself quite dangerous, using a built-in user like that.
That's the really insidious part, I think. Built-in accounts often fly under the radar.
How so?
Well, routine audits tend to focus on custom roles, administrator accounts people created, these default built-in ones. Sometimes they're implicitly trusted or just overlooked.
Making the whole attack much stealthier.
Highly stealthy. And the immediate thing security teams need to worry about after exploitation, it's persistence.
Ah, right. They don't just get in, they stay in.
Exactly. That unauthorized API access lets the attacker create brand new admin users or service accounts with high privileges. That gives them a solid foothold.
So even if the original readonly flaw gets patched later,
they might already have another way in, waiting.
Okay, wait. Backtrack a second. If this vulnerability lets a basic read-only user do all this, does that mean pretty much every ECE setup using defaults is vulnerable?
That's the implication, yes.
How does a flaw like this, affecting a core built-in role, even happen? You'd think that would be tested rigorously.
Well, it really highlights how complex managing permissions can get, especially across distributed systems, microservices, internal APIs.
Yeah.
It's tough. But yes, to your point, the advisory is clear.
It's not configuration dependent.
Correct. It's not about how you set up ECE. If you're running an affected version, you are vulnerable. Period. Full stop.
Okay, that is genuinely terrifying. Which brings us straight to the scope.
Yeah.
The versions affected by CVE 2025-37736.
Right, let's get specific.
It impacts ECE versions after 3.8.0 and all the way up to and including 3.8.2.
Okay.
And then also the newer 4.0 line, specifically versions after 4.0 up to and including 4.0.
Got it.
Okay.
So 3.8.1, 3.2, 4.0.1, 4.0.2 are the main ones to worry about then.
Exactly. If you're managing clusters on any of those, you need to be listening very carefully right now.
Absolutely.
Now let's get into that CVSS score. It's rated 8.8 high. That's serious. What does the vector string tell us? Especially considering it starts from low privilege.
Okay, the vector string gives us the technical breakdown. It's CVSS.3.1AV.NAC.LPR.LUI.NSUCHIHAH.
Let's decode that alphabet soup.
Right. So AVN network attackable means it can be exploited remotely over the network.
Standard, but important.
And ACL low attack complexity. Basically, it's easy to exploit. No complex hoops to jump through.
Okay, not good.
And here's the really crucial part. PRL low privilege is required.
That's the readonly user we've been talking about.
Exactly. You only need the minimal permissions of that default account to launch the attack.
Wow, okay. And the impact?
That's the CHIHAH part. High confidentiality, high integrity, high availability impact.
Maxed out across the CIA triad.
Pretty much signifies potential for full system compromise. So you put it all together.
Low effort, maximum impact.
Precisely. Low privilege requirement, PRL, leading directly to high impact across the board, HHH. I mean, that's the textbook definition of a critical vulnerability. Maximum bang for the attacker's buck with minimal effort.
Given that risk profile, fixing this isn't optional, is it?
Not even slightly. Mitigation is absolutely mandatory.
So what's the #1 immediate action item? The primary directive.
Patching. Plain and simple, it's code deployment time. Users absolutely must upgrade their ECE instances.
To which versions?
To version 3.8.3 if you're on the 3.8 line, or to version 4.0.3 if you're on the 4.0 line.
Okay, 3.8.3 or 4.0.3. That's the non-negotiable first step. It closes the door.
It closes that specific authorization vulnerability, yes.
But, and this is a big but, based on what you said earlier about persistence, the upgrade isn't the end of the story, right?
Not by a long shot. That's only half the battle.
Because the attacker might have already created those backdoors.
Exactly. You have to assume compromise if you were running one of those vulnerable versions. Assume they got in.
So what's the crucial next step? The forensic part.
You absolutely must investigate the ECE environment for indicators of compromise. IOCs.
And what are you looking for specifically?
The main IOC here is evidence of unauthorized user or service account creation. Did that readonly user, the one that shouldn't be able to, suddenly create new accounts while the system was vulnerable?
And how do you find that?
Elastic has apparently provided specific tooling to help admins list users and service accounts, presumably with creation timestamps or logs that could point back to the compromised readonly account. You need to use that tooling.
Okay, so you run the tool, you find some suspicious accounts created by readonly.
Then you just delete them.
Carefully. The advisory urges extreme caution here.
Why? If it was created maliciously, just nuke it, right?
Well, you're messing with a potentially live production system. What if an account looks suspicious? Maybe it was poorly named, but it's actually legitimate and critical for some application.
Deleting it could cause a major outage. Exactly. You could disrupt production massively. So the process needs to be: identify potential bad accounts, verify absolutely that they were created illicitly via this exploit, and then perform a controlled deletion. Treat it like careful surgery, not demolition.
Got it. Identify, verify, then remove carefully. What about organizations that, have really rigid change control? Maybe they can't patch immediately tomorrow. What's their plan B?
That's a tough spot, but they still have a critical action. Their focus must be on mitigating the persistence threat.
So even if they can't patch right away?
They absolutely must use that tooling Elastic provided immediately. List any potentially malicious users or service accounts created by the exploit.
And delete them carefully.
Yes. They'll be accepting the temporary risk of the underlying vulnerability still being there.
Which isn't great.
Not great at all, but arguably better than leaving an active attacker foothold inside their system. They essentially have to contain the damage first, then patch as soon as humanly possible. Plus, continuous monitoring becomes even more vital until they are patched.
Okay, so let's try and wrap this up, synthesize it for everyone listening.
Sounds good.
We're looking at a high-severity, universally exploitable authorization flaw in Elastic Cloud Enterprise.
Right. CVE 2025-37736.
It lets the basic, built-in, read-only user grab full control of the environment. Privilege escalation.
Complete control, potentially.
The fix requires two things. One, immediate patching to version 3.8.3 or 4.0.3.
Mandatory first step.
And two, an aggressive but careful forensic cleanup, using the provided tools to find and remove any malicious users or service accounts the attacker might have already created.
You absolutely must do both, patch and clean up.
Anything else to add? Maybe a final thought?
Yeah, just connecting it back to the bigger picture. This kind of vulnerability, a fundamental breakdown in identity and access management, IAM, within a core platform like ECE, it should really be a wake-up call.
How so?
It should make every security architect listening pause and think. Given that a simple built-in read-only role could be turned into an admin key like this, maybe we need to change our assumptions. The assumption that built-in limited access roles are inherently safe. Should we maybe start treating every built-in service account, every read-only user across all our critical platforms as a potential privilege escalation vector until we've actively proven otherwise?
Interesting. Proactive auditing of default roles.
Exactly. Maybe it's time for much deeper continuous assurance testing, specifically targeting these often overlooked built-in roles. Don't just trust the defaults. So, the homework for listeners, go audit your ECE service account configurations today.
Excellent practical advice. And a sobering thought to end on. That wraps up this deep dive into CVE 2025-37736. Thanks for breaking that down.
Glad to be here. Stay safe.
And everyone listening, stay secure out there.